Alright, so here in example 1 we have a solid lying between planes perpendicular to the x-axis at x equals 1 and x equals 4. The cross sections perpendicular to the x-axis are squares, and their heights are defined by the equation y equals x squared. We're trying to find the volume of the solid. The first step that we're going to take is to sketch a curve here. So I'm going to go ahead and sketch y equals x squared, something like that. And we have a solid between x equals 1 and x equals 4. Okay. Now, I could go through the process of actually sketching the solid itself, but I'm not going to do that in this case. You just kind of have to imagine that what we have is we have a square at each of these locations, and the side length of the square is the same as the height of the curve. And so if we identify, there's the height of the curve at this one particular point. If you imagine a square coming out of your screen that has the same dimension coming out of your screen as it does on the surface of your screen, then you've got your square, and those squares grow as we move from left to right on this interval. So we're going to take this particular slice that I've taken, and it forms a square in our solid. So what I'm going to do is go ahead and draw that square, and we'll grab that square and slide it out of there. And this is what that particular slice looks like when we slice that piece out of the solid. So our next task, now that we've got a sketch of the curve and a typical cross-section, is going to be to figure out the area of that cross-section. Now we know that this particular dimension of the square is x squared, and so the other dimension of the square is x squared, and so our area formula for this cross-sectional solid, this particular cross-section, the area is going to be x squared squared, or just x to the 4th. And so now in order to find the volume of the solid, we are going to set up an integral where x to the 4th is our integrand. And we need to integrate that from one end to the other of the region. And so we're going to integrate it from x equals 1 to x equals 4, since that's where the solid starts and where the solid ends. And at this point in time, I have, two choices. I can either choose to integrate this by hand, or I can use a graphing calculator to integrate numerically. I'm going to go ahead and integrate this one by hand since it's reasonably simple. My antiderivative is x to the 5th over 5, which we're going to evaluate from 1 to 4. And so we've got 4 to the 5th over 5 minus 1 to the 5th over 5. And let's see, 4 to the 5th, that's 1,024 over 5 minus 1 over 5. And so we end up with our volume for this solid being 1,023 over 5, or 204.6. And you can go ahead and use the numerical integral feature on your calculator to confirm that that's the same value that you get, and it should be. All right?